So, hello everyone, and welcome to this live discussion that we have. Ask AuxEn Anything, and as you all know, this is an online platform for civil structural engineers to interact with us and ask their queries, doubts, or difficulties related to any RCC steel design concept or construction site issues or project related queries. So, this is the 32nd such episode that we are conducting, and let us start with this session. So, as we do always, I'll take up the queries from the I'll take up the queries from the Google form to begin with, and then we will look at the queries that have been asked on the mail, and then in the live comments, if there are any questions, we'll take them up. Okay, so let's start. And the first question is from Mr. Rohit Raghav. He is a postgraduate student and he is joining from Faridabad. So his question is this. This is his question that he's asking. I hope the question is visible on the screen. So in your course, you have mentioned that we should keep the utilization ratio around zero point 0.7 to zero point 0.8 for connection design considerations. But nowadays, many structural engineers increase the ratio up to 0.95. This, this. In such cases, how can we find out the updated UR? So what he's saying is, and what I had mentioned in the course, let's say you are designing any steel structure, okay? At the time of steel structure design, let's say at the time of member design that you are doing, you are not you have not worked out the connection assembly yet. Okay, so if this was my column, let's say, and this was my beam, so when you are working out the member design, till that time, let's say you are doing it on stat, so at the time of member design you are not sure about the connections, you have not finalized your connections. So in such a case, what may happen is that, especially this statement is especially true for tension members, what may happen for tension members, that you may face failures in tension member at connection level. What does it mean, failure in tension members at connection level? Why you may face failures? Can anyone answer? At connection level, why you may face failure in tension members? What's the reason? So the reason is because at in tension members, there is reduction of area at connection level. If you are going ahead with bolted connections, so there is a reduction of area at the connection level. So due to this reduction of the member area or cross sectional area at the connection level, it may happen that there is a failure either in rupture, okay, or in block shear. You may face failures. So therefore, in such cases, what do we do? In such cases, what do we do is that at the initial level, when we are designing our members and when we are not sure about the connection assembly, we try to keep, let's say, a slightly lower utilization ratio, let's say around zero point 0.7 to zero point 0.8. And this statement is especially true for tension members. So while designing the members or while finalizing the member sizes, we'll try to keep a lower utilization ratio. See, technically, we are allowed to keep a utilization ratio as close as possible to 1, isn't it? Because we want the ratio to be less than 1. So, as close as possible to 1, you are allowed to keep. But I am saying that in tension members, I will try to keep a UR of zero point 0.7 to zero point 0.8. And this, why I'm doing is to account for any later on problems that I may face at connection level. So let's say I keep a utilization ratio of zero point 0.7 to zero point 0.8 member ratio. And then when I am checking at connection level, net area in rupture and in block shear, I will see that the utilization ratio or the connection will then, or the member at the connection level will also be almost okay. So that is the reason I had mentioned this statement. So now let us look at this question once again. In course, you mentioned that we should keep the UR around 0.78, 0.7 to 0.8 due to connection design considerations. But nowadays, many structural engineers increase the UR up to 0.95. See, this is more valid for this 0.95 that you are saying is for more for columns, beams, all other elements which are mostly going to have compression and flexure. So if your member has compression or flexure, at the connection level, you will not find any major difference in the utilization ratio. So when you will go on to design the connections for members which are in compression or in flexure or in shear, you will not see any major change at the connection level also, because there is no reduction in the net area, or reduction in net area don't affect the members which are in compression or flexure. Mostly they don't affect. So that's why if you are seeing this, that engineers are keeping it up to 0.95, of course they will check at the connection level also, and accordingly they will design their connections. But here the point I'm trying to make, that the engineers, structural engineers, are taking it up to 0.95 because they know that it is for such members where the connection assembly is not going to affect uh, the member at connection level. So that is the reason they take up this decision. Okay. Okay. So this is the answer. So this was the question asked by engineer Rohit Raghav, and now I'll just take up the next question. So next question is from uh, next question is not a question, it is a comment from engineer Arbaz Kazi. He is a working professional. And what is this comment? Till when can we expect a composite design course as per AISC and concrete design course as per ACI 318? So right now we are doing a steel design course as per AISC. It's a detailed comprehensive steel design course as per AISC we are doing right now. Then we will take up a concrete design course. It will be an in-depth comprehensive concrete design course as per the ACI 318 code. Once this is done, then we will do a composite design. So for composite design, because you need to know steel and concrete, so right now we are doing steel, then we will do a concrete design course. After that, we will take up a course maybe on composite design. Okay. Then the next question is from engineer Rupak Raj. He is a working professional joining us from Noida. He is asking how many types of analysis, how many type of analysis we use to analyze the structure. Why, when, how? Arre, what is why, when, how? Type of analysis we use to analyze the structure. I'm not sure what he's trying to ask. What is meant by type of analysis? Type of analysis. How many type of analysis? I don't know. Type of analysis, what does it mean? Any idea, anyone in the audience? His question is how many type of analysis we use to analyze the structure. I don't know. Maybe one will be a linear static analysis, let's say, where or linear elastic analysis, I'll put it this way, which is the normal form of analysis that you do. Sometimes for some structures, you may have to do a non-linear, or I will put it geometry. Sometimes you may have to consider, let's say, a second order analysis, which is often called as a p delta analysis. Here we consider the geometric nonlinearity. So the member deformations we consider in this kind of an analysis. Okay. Material nonlinearity, generally we do not consider material nonlinearity in our normal practicing engineers. I've not seen practicing engineers considering, and we don't know it well also. So we don't usually consider the material nonlinearity in any of our analysis. So one is, let's say, the linear elastic analysis that we usually do. Other can be a second order analysis where we consider the geometric nonlinearity. Uh, I don't know what other analysis do we use. If it comes to the earthquake loads, then mostly we are doing a linear static analysis. This is called as the equivalent static method. Sometimes we may do a modal analysis, or what is also called as a response spectrum analysis. So this is mostly a linear dynamic analysis that we do. Okay, this is nothing but the response spectrum method. And other analysis where we consider the material nonlinearity uh, can be your pushover analysis or other methods which we as a practicing engineers don't usually do. So if you're asking about types of analysis, these are the usual types of analysis that you could come across. Now if I talk specifically about, let's say, steel structures, or if I talk about the stability aspect, if you want to check the stability of structures, then especially in the AISC standard, there is a analysis procedure called as the direct analysis method, where we do some stiffness modification and other aspects are considered. So that's a direct analysis method, but it's a method, it's not an analysis type in itself. It's a analysis procedure that is given. So essentially we are over there we are considering linear elastic analysis, plus then we are considering some second order effects also, and uh, then we are also considering the modifiers and those things we are doing it. But it's not an analysis procedure. I mean, it's not an analysis method, it's more of an analysis procedure that we follow. Shavantika ji is saying ULS and SLS, those are limit states. Those are, one is your ultimate limit state and the other is the serviceability limit state. So that is the load level at which we are checking different effects. That's not an analysis procedure. Those are not separate analysis procedures. Those are different load levels at which we are checking effects in our structure. Okay. So you cannot call these two limit states as different analysis procedures. All right. Yeah, you may also say that for some structures, you may also say over here that for some structures, we may do additional analysis, like maybe the construction stage analysis. So it's over there also we consider the geometric nonlinearity and we do the step analysis as per the construction sequence. So again, it's an analysis procedure, it's not a different sort of analysis that we are doing. So all these things that I have listed down are your different analysis procedures that are given by your code to be checked under different conditions. Okay. So I mean, to the best of my understanding, I have tried to answer this question. Then the next question is from engineer Abhijit. He is joining us from Pune, and he's a working professional. Please explain how to provide shear reinforcement in. So this is from engineer Abhijit from Pune. He is a working professional and he's asking, please explain how to provide shear reinforcement in drop ODLF. I don't understand. In drop, slab, footing, and retaining wall to restrict depth of drop, footing, and width of retaining wall. See, in slab, the basic principle is in slabs or drop panels in your flat slabs or footings or retaining walls. The basic principle in these structures is that we try to uh, resist the shear. We try to resist the shear by concrete alone. That is the basic philosophy we use. So the total shear is taken by, in normal conditions, it is taken by concrete plus stirrups. So let's say if you're designing a beam, we would do this where the total shear would be taken by concrete and stirrups both. In case of these elements like slabs or drops or footings or retaining walls or even walls in your tanks, liquid retaining structures, in all these cases, what we try to do is we try to resist the shear by VC alone. Why do we do it this way? Why so? Can anyone tell me? My question is that why in beams I am happy to provide stirrups and longitudinal reinforcement, while in slabs I don't want to provide stirrups. What's the reason behind it? Hello. While in slabs, why do I not want to provide stirrups? Tell me. Why I'm unhappy with providing stirrups in slabs? And why do I want to take the entire shear by concrete alone? So the reason, very simple reason, is that it is complicated constructionally and execution wise. It's complicated to provide stirrups in these elements like slabs or drops or footings or retaining walls or tank walls, etc. It takes time because what will happen, you'll have to keep on providing these multiple links, and it will have to be provided in this along at different reinforcements like this, and then also you will have to distribute it in the plan dimension. So it is complicated. Therefore, as far as possible, you want to avoid providing shear reinforcements. Generally, we try to avoid providing shear reinforcements in these types of elements. But if it has to be provided, of course, you can carry out the design in the normal manner in which you do the shear design. So the principle remains the same. Total shear has to be taken by VC plus stirrups. Let me write it as VU over here. So the total shear has to be taken by concrete and stirrups. So for concrete, you know it is equal to tau C BD. This tau C you can get from table 19 of our IS 456. So from there you can get the tau C. B and D will depend on what element you are using. Accordingly, you can calculate B and D. And once that is known, you find out or you calculate this VU minus VC to get the stirrups, V stirrups or the shear to be taken by stirrups, and then you can find out the stirrup reinforcement. So again, the stirrup reinforcement, if you are providing in terms of single links, then for each link how much it is taking, you can find that out. Okay, for example 0.87 FY AST. If you are providing single links, one link will take this much shear. All right. If you are providing it in a slab-like arrangement, you can use our formula 0.87 Fy ASV D upon SV. If you are providing bent up bars to resist the shear, then accordingly you can use that formula sine alpha. So it will depend on what type of arrangement you are going to provide. Accordingly you can provide shear reinforcement. So in all these elements, I'll repeat, shear reinforcements can be provided. They are provided to restrict the depths. We have done a lot of projects where we have provided shear reinforcements in all these elements, and you can follow this procedure to provide the shear reinforcement, just like you do your normal shear reinforcement design for beams. Same manner you can do it over here also. It is just that depending on the element and depending on in the manner in which you are going to provide shear reinforcement, uh, these formulae may differ. Okay. Then his next question is, what is the cutoff level of pile? Means what care to be taken by structural engineer related to pile and pile cap level. See, cutoff level is basically where you will be stopping your pile casting. So this means that, let's say I have my pile cap like this, and this is my pile. Okay. Now generally, so understand, let's say, let's take some quick example. So let's say this was your ground level. This was your natural ground level, and maybe your finished ground level was here, which was some, hmm, wait a minute. Let's say this is your natural ground level, and this is your finished ground level, and let's say it is 450 mm up. Your total pile cap depth was 1000. Okay. So what is this depth then? So it is 550. Yeah. Now ideally what you want is, and let's say this is 300 dia pile that you are using. So ideally what happens is that we generally cast our pile to a greater length, and then we break some portion of the pile. Does anyone know why do we break some portion of the pile? Hello? Does anyone know why do we break some portion of the pile? So we break some portion of the pile because what happens is that during the pile concreting, there is a possibility that while we are doing the concreting of pile, some soil substances or some deleterious matters may fall into this pile hole or pile bore. And when we are doing the concreting, filling it with concrete, generally what happens that those deleterious materials, because they are light, they rise up to the surface, top surface. Also, the bleeding water due to segregation, that bleeding water, what we call it as, that also rises up to the surface, top surface. So generally this top surface is the weaker zone in your pile length. So what we do is that we cast an extra length of pile. Generally we take it up to 1 dia, or some people take it up to 1.5 dia also. So let's say I take it up to 1 dia. So what I will do, I'll cast 300 mm extra. So I'll be casting my concrete till this level. Sorry, I will be casting my pile till this level. So what will be this depth then below NGL? So this depth below NGL will be, from here to here was 550 and 300. So it will be 250 mm below NGL, correct? Hello. It will be 250 mm below NGL. So this 250 mm below NGL till which we are going to cast our pile is called as the cutoff level. So basically we are going to cast our pile till this level. This will be called as the cutoff level. Once we do this concreting, and once the concrete has hardened, then we will break this, and then this is called as the chip off level. Is it clear? So this is the meaning of cutoff level in pile and chip off level or chip off length. So the care that you need to take is what care needs to be taken by structural engineer. No care, you don't. I mean, care means you just need to calculate your cutoff levels accurately, and it will depend on your pile cap depth, what levels, what top level you are maintaining for your pile cap, and all those things will decide that how you will find out the cutoff level. Okay, the basic concept is this what I have explained. Okay, next let's go to next question. So the next question asked is there are couple of no more than couple of questions asked by engineer Alek Khatwal. He is joining us from Kathmandu, Nepal, and he is saying uh, he is asking these questions. What is the difference of modeling in idea? His first question is what is the difference of modeling in idea statica with predefined model and blank model. So predefined model, there are some templates that are already there. It saves your time in modeling, and if you are starting from blank model, you are starting from scratch. You will have to create that entire model on your own. So that is the difference. One is the predefined templates that you have, it will save some of your time, and the other is where you are creating a model from a clean slate, from blank model. If you're creating, it will take some time in modeling. Personally, I prefer to go with the blank model and start it and do all things on my own instead of using templates. His next question is, can you please elaborate on beam column capacity ratio calculation? So you need to maintain, as per the ductile design and detailing philosophy, we want columns to be stronger than that of beams. So that this is also often called as strong column weak beam concept. So we want that the summation of moment carrying capacity of column divided by, or this should be, let's put it this way, greater than summation of moment carrying capacity of beams. So at a beam column joint, if this was the cross section of my joint, these blue things are my column, and these pink lines are my beams, and this is a particular joint. Let's say this is the column above, this is column below, this is the beam to left, beam to right. So what I want, that the moment carrying capacity of column above plus moment carrying capacity of column below has to be greater than the moment carrying capacity of beam to left plus moment carrying capacity of beam to right. This is the basic concept. Now, as per different codal provisions, some codes are not just satisfied with this. They give you some additional ratio that columns have to be 1.2 times as strong as beams. Okay, or some codes give you 1.4 times as strong as that of beams, or 1.1 times as strong as that of beams. So different country codes give you these different ratios to be maintained, but the basic principle is this, where you need to calculate the summation of moment capacity of beams, you calculate the summation of moment capacity of columns, and then ensure this ratio is maintained. Software like etabs are able to do these things on their own, so you may refer to such softwares. uh, IS 13920 gives you the appropriate procedure to do this calculation, so you can refer to that as well. His next question is, while applying wind load on building, is it a good practice to apply on sheet or purlin? No, you are not modeling sheet, I suppose. Generally, we are not modeling the sheet, isn't it? So we are modeling purlins, let's say, or sometimes we are not even modeling purlins. So we only have the rafters, or let's say we only have the rafters and columns and beams or whatever. So you need to apply the wind loads as per the elements that you have modeled and as per the load path. So your general load path will be, let's say, from sheeting to purlin or girts, and from there to your rafter or beam or column, whichever element you have. and from there to, let's say, your column or whatever, and from there to your foundation. So let's say if you have modeled purlin and guts, you apply your wind loads on purlin's guts. If you have not modeled purlin's guts, then you apply the loads on rafter beams, columns, etc. So depending on what item you have modeled, accordingly you can apply the wind load on it. If you have modeled the sheeting, let's say, if you have modeled the sheeting, though nobody models the sheet, then you can directly apply the wind load in pressure terms, kilonewton per meter square. If you have not modeled the sheeting, only modeled purlins and guts, you can apply it in form of a UDL load on purlins guts. Same case for these also. So it will depend on what elements you have modeled and what is the load path according to which you can provide these loads. Then his next question is, what is the major difference between shear and moment connection in steel connection design? So a shear connection, when I say it is designed only to take shears, a shear connection is designed only to take shears, only to take shear. So it will not resist any moment. So this is more like a pin-like connection. And in moment connections of course take both. So moment connections will take shear and moments both. So they are designed like moment connections, and they may also be designed as rigid connections if adequate stiffness is provided. So the basic difference between shear and moment connection is that a shear connection can resist only shears, while a moment connection will resist both moments and shears. So these were the queries from Engineer Alek. And now moving on, this is the question asked by Engineer Abdul Khaliku. He is joining us from Riyadh, Saudi Arabia, and he is saying, I think for that I'll just put an image over here for better understanding. Let me just try to search that image. Just give me a minute. I am searching for that image that he had put in the WhatsApp chat. I'm just trying to uh, put a query in WhatsApp which one of our participants had asked. So he had shared one design calculation, and here he is asking It was a facade system that he was designing, I guess. And his query is, so this was the image that he had shared. It's a screenshot from a design calculation, and this is a facade system made out of wire ropes. Made of wire ropes. So basically, what I understand is that, let's say this is your whatever, this is your building envelope, this is your RCC column, let's say, and you might have some RCC elements, and then over here, what you are doing, this is the sectional view I'm showing you. So you will have a cable. This is a cable, and this cable will be tightened, pre-tensioned, and then on this pre-tensioned cable, you have fixed your facade system. So this will resist the wind forces or whatever are uh, to be expected to be taken. It will resist the forces. So his question was, how do we decide this pre-tension force? So my answer to his query was that this pre-tension force will be decided. Pre-tension force means by how much force you need to tighten your cable with. Okay, how much pre-tension force you need to put in this cable. Now, why we would need to put a pre-tension force in the cable? Because otherwise, this cable will not be able to hold its position, and if it's not able to hold its position, it will not give you the required lateral resistance. Are you getting it? It will not give you the required lateral resistance. So, to get the lateral resistance required, you will have to pre-tension the cable so that it maintains a certain tightness, and then when designed for lateral load, it's able to maintain its deflection value. So his question was, how do we decide this pre-tension? So my answer to him was that this pre-tension force will be decided by, number one, this length. Okay, number two will be the expected loads, and number three, it will be the maximum deflection you're allowed to have in this facade system. So depending on all these aspects, you will come up with this pre-tension force. This is what I understand. Of course, for details you will need to study the design for such cable systems, which I am not sure. I'm not sure about the mathematics of it, but logically this is how you will need to approach. You need to know the length, or let's say in this case the height over which you are going to provide the cable. Then you need to know how much force is expected on this facade system which will be transferred to the cable, and then you also need to know how much deflection limit has to be maintained. Accordingly, you will find out the pretension force. Of course, if you want to maintain lower deflections in this, you will need a higher pretension force. Okay, if you're allowed to go for a greater deflection value, you will need lower pretension force. So in this manner, the pretension force will be found out. Okay. Then the next question was asked by Mr. Tamilar Hasan. Just hold on, I'll be back. Yeah. Then the next question asked was by engineer Tamilar Hasan. He is asking, while designing compound wall with brickwork, let me just copy his question. and put it over here. While designing compound wall with brickwork and RC column and footing, so he's saying compound wall with brickwork and RC column. So let's say these are his RC columns. I'm trying to draw an elevation, and these will have footings, and then this is the brickwork. Let's make another RC. Okay, will be transferred to RC column. Some of the consultant states brick wall stands alone, and block will not transfer wind to column. Some of the consultants states wind force acting on brickwork will be transferred to column and column to be designed for wind force. My question is, will mortar have the strength to transfer force wind from brick wall to column for 12 feet height compound wall? Very good. So he's saying that some people design this brick wall as standalone. So let's say they will say that there is a gap between the brick wall and the column. So whatever wind loads are there, that wind load will be taken by this brick wall, and assume, let's say that there is a beam over here. So those wind forces will be directly transferred to the beam. So in such cases, this becomes a load bearing wall, of course. Okay, this becomes a load bearing wall. So in load bearing walls subjected to lateral loads, there is a particular code that you need to refer to. There is an Indian standard. I am not able to recall that Indian standard number, but there is a IS code which does the calculation for these load bearing walls. Okay, and load bearing walls, this will be a load bearing wall subjected to lateral loads. So in that, it also calculates the mortar stresses, because what will happen, see, just try and understand that if I were to draw a cross section of this, what will happen in this case, that imagine we are going for a standalone wall right now. So what will happen in this case, that this will be a beam, this will be a beam, and this becomes your brick wall. Okay, in sectional view. Now what you need to check, that whatever wind forces are going to act on this lateral loads, it will create some stresses at the base. Okay, you can calculate the stresses as m by z, where z will be dependent on this depth. Okay, so z will become whatever is the width you are considering in the other direction, bd square upon 6. So this becomes the stress. So now you need to check the tensile stresses that will be developed. These tensile stresses, whether your mortar is sufficient to take them, and also whether your this width is sufficient enough or not. So these calculations and the permissible mortar stresses is given in this Indian standard. I am forgetting the name of this Indian standard, but for load bearing masonry, you have this Indian standard, and it does the checking for lateral loads also. So you can refer to those calculations for better understanding. If your standalone walls are not sufficient, then what you can say is that then you will not try to provide this gap, and instead try to cast it with the columns itself, and then it becomes a panel, just like a two-way arrangement. So for these cases also, this code that I'm talking about, it does give you some guidelines on the calculation. So if your standalone brick wall panel is not sufficient, then you will integrate your brick walls with the RCC element, and then you do the checking. Is it understood? So refer to that code. I am forgetting the code number right now. Okay. Then we have another question from engineer Rupak Raj. While calculating open structure wind loads, uh, Please explain how to calculate the frame spacing ratio. So frame spacing ratio is nothing. Let's say in plan view you have this frame. This is the plan view I'm showing you, and this is the frame 2 in plan view, and wind loads are acting like this. Then what the code defines as the frame spacing ratio is this distance b upon the least dimension of the member in frame 1 and 2. So basically, if let's say this b was 6 meters, let's say, and here I was using members which were having a least dimension of 75 mm. Okay, suppose I was using an angle ISA 75, 75, 6. So 75 becomes my least dimension. So the frame spacing ratio will be this 6 meter divided by this 75. This becomes my frame spacing ratio. And on the basis of this frame spacing ratio, you can calculate the shielding effect. So on the basis of this frame spacing ratio, and uh, yeah, you calculate the shielding effect. Solidity ratio and frame spacing ratio, you will calculate the shielding effect. There is a very good document made by Abhay Gupta sir related to the wind calculations. Different conditions and different examples are given over there. That document has been prepared, I think, by GSDMA. So that document is easily available on the internet. You can download that document. It is called as Explanatory Handbook on. I'll just show you a screenshot. You can download it from the internet also, or you can just message me. I'll share the PDF. So this is that document. Are you able to see this? So this has been prepared by Dr. Abhay Gupta sir, and it's a very good document where around 29-30 examples are given, which cover the different conditions for wind load application. So I'll recommend everyone to go through this document. They will understand how to apply wind loads for different conditions. Okay. All right. Let's take up some queries that have been asked in the live comments. So engineer Rishabh Thakre is saying, in construction stage analysis, axial deformation which occurs, is it okay to fill columns higher than required at all floors or at certain floors only? Yeah, so what happens is that when we do the axial deformation, generally at every floor, let's say for tall buildings I'm talking about, let's say you get some 7 8 mm 10 mm axial deformation. Okay, of course it will increase with the number of floors. So at the lower floors you will have more axial deformation in the columns. At higher floors you will have lesser axial deformation. So instead of casting my columns higher at every level, what we do is we generally club the axial deformations at 7 8 floors, let's say, and then whatever extra we need to cast, we will do the casting after every 7 8 floors. So instead of casting at every level, instead of considering the additional casting, what we do is we group or we accumulate those different axial deformation values, and then we will group those values or sum up those values for 7 8 10 floors, and then at every 10 floors 12 floors we will do the extra casting. So instead of casting at every floor, we will do it this way. Okay. Mr. Akash Babar is asking, please explain reinforcement details of Y-shaped columns. No, I mean, what is the thing that you want to understand? Whatever reinforcements you are getting, you need to provide that. So you need to have, let's say you had a Y-shaped column in, is it in sectional view you are saying, or your Y-shaped column is like this? in elevation. So this is one column, this is another column, and at down level, this is what you have. Is this the Y-shaped column you are saying, or you have a Y shape in plan? Maybe you could provide some sketch for better clarity. Mr. Venkatesh is asking, can we distribute the minimum reinforcement of steel in both faces, or each face should contain minimum reinforcement of steel as indicated by code? No, it is, see, again, it depends clause to clause. For example, in case of slabs, I think that minimum reinforcement criteria is on each tension face in each direction, if I remember correctly. In case of beams, if you look at the minimum web reinforcement that we have to provide, minimum side face reinforcement, then it is to be distributed equally on both faces. In case of footings, if you have to provide certain minimum face reinforcement, it is on each face. So it depends clause to clause. So whichever minimum reinforcement clause you are following, you refer that clause and see the related provision. Mr. Akash is saying floating column is okay. So he has given the details of this Y column. Floating column is starting from free end of cantilever, and column below is stopping at the level of cantilever beam. Okay, so he's saying that let's say in sectional view, this is my column and this is cantilever, and then this is the column that is starting floating. This is the column below. This is the cantilever. So what is the question? I'm not sure about the question. Yeah. Maybe you could provide some sketch. Mr. Venkatesh is asking how to carry out vibration analysis of slab. Is model analysis sufficient to identify the natural frequency of slab and keep the frequency under the limit as mentioned in the code? Yes, so there are different procedures given in the code for vibration analysis. One is there are some approximate methods. So in one case, the vibration analysis is correlated with the deflection. It is correlated with the deflection. Here I am talking about the vibration in the gravity direction. So one way is to correlate the vibration with the deflection of your slab. So there are some approximate formula given for that. One other way is to conduct an actual frequency analysis where you will calculate the frequency, model frequency you will calculate, and you will compare it with the allowable frequency value given in the code. So that is the another way. So depending on the procedure that you are adopting, you may do the vibration analysis. As I told you in documents also, if you read, one is this approximate method where they will calculate the deflection of the slab and then correlate it with the vibration. In another methods, you can calculate the actual vibrating frequency of slab and compare it with the allowable limit in the code. Yes. Mr. Magaj is asking the next question. Can we take ramp and staircase as a support to design the retaining wall as propped cantilever, or it has to be designed as a cantilever? No, you can take the support of ramp and staircase and take it to be providing a prop to your retaining wall. But of course, you need to carefully consider all the conditions. For example, in plan view, if my staircase is covering only a very small portion of your retaining wall length, so maybe this is the plan view. So maybe here you are getting the retaining wall as a prop, but in other locations you are not getting the effect of staircase. So you have to be careful about what condition you have, but you can consider the uh, staircase to be acting as a prop to your retaining wall. Mr. Rishabh Thackeray is saying if depth is added at every 10 floors, won't it deform at each floor as per casting of 9 floors and we are compensating at 10th floor only? No, that is true, but then 4 5 mm here and there in your structures is not a problem. That's what I'm trying to explain. 4 5 mm at every level, it's not a problem for you. Okay, in structural terms, you don't have to worry. So therefore, instead of doing maintaining the levels at every floor, what we do is we will try to add up, accumulate, and try to compensate after every certain number of floors instead of doing the compensation at every floor. Got it? Yeah. See, for a building of 300-meter height, 400-meter height, every floor around 5-10 mm here and there is not a worry for you. But cumulatively, if in 300 meters it was having a 200 mm axial deformation, cumulative value is of course a problem. But every one floor, if you see it's only 5-10 mm, 15 mm, that's not a problem. So to be practical, what do we do? And for ease of construction, we will accumulate these actual deformations and uh, do the additional casting after every 10-12 floors, whatever you decide depending on the actual deformation values. All right. So these are the questions that we were asked today. We have taken all the questions asked in the Google form and on the live comments. So I think that's it for this session then. We will thank you for joining us today. We will see you next week now with further questions and queries. So the Google form remains the same. You can continue to keep on adding those questions. You need not wait for the session to put in your queries. You can keep putting your queries throughout the week, and generally on weekend we conduct this live session to take up your queries. So this is the link for the form, Google form, where you can ask your queries. And if you want to connect with us on WhatsApp, then you can click on this link, which I'm just putting in the live comment. Let me just put that link. So this is the link if you want to connect with us or message us on WhatsApp. Okay. All right. So that's all for this session. Mr. Rishabh is asking, does construction stage analysis creep deformation to be considered in steel building also? Steel building generally don't show such problems of creep. So creep related problems are seen more in the RCC buildings. So in steel generally creep deformations are not observed. Number one is because we are not stressing the steel to that levels of stresses. So creep deformations is not a major cause of concern in steel buildings as such. Okay. All right. So this is the link whereby you can directly message us on WhatsApp. So this is all we have for this week. Thank you so much, and we will see you next weekend now. Bye bye.